Today we're just going to derive some equation in kinematics in one dimension. So as we know with these equations here to the right side. So as we know, we have this, we already know what is this, what those things means. That acceleration is the change in velocity for time, velocity is the change in displacement over time. So let's go ahead and derive the first equation, which is B final is equal to B initial plus acceleration times time. Okay, now, so let's do it. So we all know we have this acceleration by definition is equal to the change in velocity over time, and we're just going to cross multiply and solve for the B final. So as we can see, it's pretty easy to derive the first one. So I'm just going to put the box once I derive it. Okay, now let's derive the other one here. This distance equals to 1/2 multiplied by the sum of B final plus B initial multiplied by time. So we need to know this equation that distance is equals to the average velocity times time when it is on a constant velocity. So this is basically the equation if it is on a constant speed or constant velocity. The V bar is just the average velocity. So the average is going to be this thing. So we can replace that, the V bar with this, and moving the 1/2 to the left, or factoring out 1/2, so we get this. So that is it. That's how to derive that equation. So we already have that. We're just going to box it. Now let's try this. This thing. Okay. V final squared is equal to V initial squared plus 280. So how do we derive it? So we can just derive it by these equations that we have derived earlier. So V final is equal to V initial plus acceleration times time. And we also have this equation, right? We have the distance equals to the average velocity time multiplied by time. Now what we can do here is just solve for the time. So we will get this on the left one. And for this one, we're going to solve for the time. So multiplying both sides by 2. And we can distribute this p, or we can just leave it like that and just to divide both sides. So now what we're going to do is just divide both sides by V final plus V initial. So what we can get is this thing. Okay, now we can just set time and time equal together. I'm gonna delete this one. You gotta save these equations because we're going to use it a lot in kinematics. So here, now we can just cross multiply. So we're just going to cross multiply this. What will happen is A2 or 2AD. Just here, there you have it. And also we have this thing, the quantity of V final minus V initial multiplied by the quantity of P final plus V initial. And then as we can see, it's just difference of perfect squares. So we can just write it as V final squared minus V initial squared. Now moving V initial squared to the left side, we can just rearrange our equation, and this is going to be V final squared equals to V initial squared plus 2AD. So they look alike. So this is the equation for that thing. Now let's look to the last one. The equals to V initial plus 1/2 acceleration times time squared. So as we know that we have this equation, distance is equals to 1/2 B final plus V initial times time, and we also have this equation. So what we can do is just replace B final with v initial plus acceleration times time. So we got this. Okay, now we can just combine like terms. Cool. So we're going to combine v initial. So we got 2v initial plus acceleration and time. And then what we can do is just distribute. I mean, yeah, let's just distribute 1/2. So we get is v initial plus 1/2 acceleration in time. We still haven't distributed the t. Now we can just distribute the t. So we got v initial times t plus 1/2 acceleration times time squared. So we do miss a t on the function of the equation. So we're just going to put it here. You miss it. Luckily, I just derived it, so we find our mistake. Okay, now, so this is it. This is the kinematics in one dimension, and kindly write it down.